Welcome to your Finite Math R5 lesson. Today you will be solving and graphing inequalities. When graphing inequalities, remember, for less than and greater than, you use an open circle for an endpoint. For less than or equal to and greater than or equal to, you use a closed circle for an endpoint. So if you use the extra pencil lead to draw the line underneath the inequality sign, you're going to use extra pencil lead to color in the circle. Solutions can be written in interval notation. Parentheses are used for open circle endpoints and arrows. Brackets are used for closed circle endpoints. We're going to write the following inequalities in interval notation and graph each interval. So we have x less than -5. Now I think it's easiest to go ahead and graph the inequality and then translate it to interval notation. So that's what I'll do here. Now you can number the numbers on your number line either above or below. Doesn't matter to me. But you do need to mark at least -5 and a couple of other values. So let's see, it's x less than -5 because it's strictly less than. You're going to have an open circle. The values that are less than -5 are to the left of -5, so we color in the arrow in that direction. Now for interval notation, we need to consider that as you go to the far left, that is in the direction of negative infinity. If we were going to go to the far right, that's in the direction of positive infinity, because that's going to be important in interval notation. So for interval notation, because we have an arrow here, we use a parenthesis, one of two parentheses there, and then we say we come in from the direction of negative infinity. This doesn't ever end, it just keeps on going and going. So we come in from the direction of negative infinity, and then we go up to -5, so it's left to right, lower bound, upper bound. And then we use another parenthesis because this is an open circle. If this were colored in, if it were a closed circle, we'd have a bracket, but it's not. So this means every value coming up from the direction of negative infinity up to, but not including -5. All right, let's look at x greater than or equal to -6. Let's graph it. We have a closed circle at -6 because of the or equal to, and then we go to the right because the values to the right of -6 are greater than -6. So we go in the direction of positive infinity. All right, because -6 has a closed endpoint, it's going to have a bracket, and we always write from left to right. So we do bracket, -6, comma, so -6 is our lower bound. Really, in the upper bound position, it's unbounded, and so we don't have a number. We have that it keeps going in the direction of positive infinity. And because it's an arrow, because it is unbounded, we have a parenthesis there. What if we have two numbers? What if it's -3 less than x less than or equal to 8? Well, again, graph it. So at -3, we have an open endpoint because it's -3 is strictly less than x. And then we have all these x values, and we end with a closed endpoint at 8. And so -3 to 8. So -3 has a parenthesis, and we go from -3, comma 8. 8 has a bracket because it has a closed endpoint. All right, let's look at x less than or equal to -3 or x greater than or equal to 7. So whenever you have an or statement, you're going to have two separate intervals drawn in. X less than or equal to -3. We have a closed endpoint at -3, and we shade to the left because we draw in our arrow to the left because those are the values that are less than -3. And then we handle the x greater than or equal to 7 separately. So we color in the endpoint at 7, and we go to the right. So the way we write this is we do parenthesis, negative infinity, comma, -3, bracket, because -3 is included in the solution because we had the or equal to part. And then we use the union symbol. It's like a big fat uppercase U. It's wider than maybe what you would think the uppercase U would be. And then we do our next endpoint 7 and indicate that we keep going toward positive infinity. And we have a parenthesis there because it is unbounded. We're going to write the following again in interval notation and graph. So we've got negative infinity less than x less than infinity. Well, that means we're going to extend all the way in the direction of negative infinity, all the way in the direction of positive infinity. That's just all real numbers, so the whole number line is colored in. And the way we just write that, we go from left to right, so we have parenthesis, negative infinity, comma, positive infinity, close parenthesis. All right, when you multiply or divide both sides of an inequality by a negative, remember you have to reverse the direction of the inequality. Okay, so we're going to solve the following, same direction, solve the following inequalities and write your answers graphically in an interval notation. So we're actually going to have to do some solving here. For inequalities, we like our x's to be on the left-hand side. So we would subtract 4x from both sides to give us negative x. And then we'd add 7 to both sides to give us 12. Negative x is greater than 12. That's great, but we want to know something about x. So we need to divide by negative 1. And that reverses the inequality. So you end up with x less than negative 12. So again, you have an open endpoint at negative 12, and your arrow is going to extend to the left in the direction of negative infinity. So writing your answer in interval notation will be open parenthesis, a parenthesis there, negative infinity, comma, negative 12, and then again another parenthesis because of the open endpoint. All right, we've got negative 7 times the quantity b minus 3 is less than or equal to 21. We need to distribute the negative 7. So that gives us negative 7 plus 21 is less than or equal to 21. Sometimes people question, well, we just distributed a negative. Well, that's fine. We didn't multiply both sides of the equation by the negative 7. We just simplified the left-hand side. So we don't need to reverse any inequality sign right now. All right, so let's subtract 21 from both sides. We get negative 7b is less than or equal to 0. Now we need to divide both sides by negative 7. So we're going to get b greater than or equal to 0 because 0 divided by negative 7 is just 0. And yes, we still reverse the inequality sign. Okay, so let's do our number line and let's plot b greater than or equal to 0. That's going to be a closed circle at 0, and then the arrow is going to extend to the right. And so, let's go ahead and we will do this together. Let's write the solution in interval notation here, just real quick. So let's see, we need a bracket, a bracket at 0, and then comma, and we need infinity there. So I need to insert a little symbol of infinity. Go grab that. There we go. And we will have a parenthesis there because you always have a parenthesis when you are working with one of the infinities, when you are indicating the direction an arrow is going in. Okay, so let's go back up here. Alrighty. So from 0 toward the direction of infinity. Alright, for part C we've got negative 13 less than or equal to y plus 3 less than or equal to 9. This is an AND statement just written very compactly. Remember from Algebra 2 it means negative 13 less than or equal to y plus 3 and y plus 3 less than or equal to 9. So remember you've got 3 parts to this. You're trying to solve for y. Whatever you have to do to get to y here in the middle, you do to both sides, on both parts to either side of the middle, so to all 3 parts. So I need to subtract 3, so I'm going to do that to all 3 parts. Negative 13 minus 3 is negative 16. Y plus 3 minus 3 is just y. 9 minus 3 is 6. So we'll graph that from negative 16 to 6. Both are less than or equal to, so we've got closed endpoints, and so negative 16 to 6 with brackets on either side is our solution. Okay guys, that's it for examples. Try the problems to try on your own. Remember, you've got to have those done to get full credit for your notes. If you need to, come see me or rewatch part of the video and try working on them again, but you want to make sure you have attempted them before you come to class. Thank you so much for watching the video and taking good notes, and I will see you in class. Have a good day.